Hello and welcome to Thoughts on Rice, a podcast hosted by the University of California Cooperative Extension Rice Advisors. I'm one of your hosts, Sarah Marsh Janish, and I'm a rice farm advisor for Colusa and Yolo counties.
I'm Whitney from DeForest. I'm the Cooperative Extension Rice Advisor for Sutter, Yuba, Placer, and Sacramento counties.
My name is Luis Espino. I'm the Rice Farming Systems Advisor for Butte and Glenn counties.
I'm Michelle Leinfelder-Miles. I'm a farm advisor in the Delta region, and the counties that I cover are San Joaquin, Sacramento, Yolo, Solano, and Contra Costa counties.
Together, the UCCE Rice Farm Advisors seek to provide relevant, topical, research-backed information relating to California rice production. Today, I have the privilege of sitting down with two scientific researchers who are really involved in some exciting projects in the rice industry. Paul Buttner, the manager of the environmental affairs at the California Rice Commission, and Carson Jeffries, a senior researcher at the UC Davis Center for Watershed Sciences and adjunct professor in the Department of Environmental Sciences and Policy. Now, I'm going to let them explain a bit more about their projects because I fear I could not do it justice. But I do just want to say thank you both so much for making the time to be here today.
Thanks for having us.
Thank you.
Well, first off, I want to just ask you both how you came to be in your respective positions at the organizations at which you work. Paul, let's start with you here.
Well, of course, I have a degree in environmental science and spent about 10 years working for the Air Resources Board before I went to Rice. When I came to Rice, I initially started working on our bird programs where we developed opportunities for rice growers to do practices for birds and get reimbursed for their costs, mostly through the Natural Resources Conservation Service. And then about 7 or 8 years ago, our board started noticing the interesting studies that were being done by Caltrout and UC Davis to show that salmon were growing quite fast within winter flooded rice fields. And so the Rice Commission board then asked me to turn my attention to salmon projects. And so I've been working on salmon ever since that time.
Great, Paul. Yeah, a bit of a shift from birds to fish, but both of them very integral, I think, to this ecosystem that we're working in. Mm-hmm. And now, Carson, same question for you. How did you end up in this, I guess, dual positions that you're working in?
No, it's funny. The various paths that we lead through life are always winding, and some are straighter than others. I actually started working for the Center for Watershed Sciences as an undergrad at UC Davis. And it just kind of led into one project after another and kind of one degree after another. And part of this was I started working on floodplains right after undergraduate and did my master's work on the Cosumnes and realizing the importance of floodplains for salmon in particular. And we realized that up until that point, salmon were supposed to kind of be in the river channels, and that was kind of where they were supposed to be. And some work by Ted Summer, DWR, early on when the Yolo bypass in the late 90s, was this first insight into the opportunities that these non-river habitats, but the floodplains might provide. And so working on the Cosumnes is a relatively small area of natural habitat. And it was pretty early on that we realized that wasn't the opportunity in the landscape. And with all the abundant rice habitat, both in the bypasses and outside of the bypasses, is we started experimenting, taking those same principles of what are the habitats and how can they work on a landscape scale that we have available to us now. And we started meeting with our rice farmer partners at that point, and it has kind of led us to the path that we're at now.
A very exciting, winding path that you're talking about here, but I think that's pretty emblematic, I'd say, of a lot of people who work in this convergence of agricultural and environmental sciences. And I love that you mentioned just the landscape and the floodplains, that the salmon you're working with to kind of rebuild their habitat. Because as I understand it, before we saw a lot of urban encroachment and agricultural encroachment across the Sacramento Valley, the salmon actually used to use the floodplains, the native floodplains. Is that correct?
Yeah, historically, prior to European settlement in the Sacramento and San Joaquin valleys, is we had millions of acres of floodplain that would inundate annually, or almost every flood event, really. And that, we would see, particularly during the spring snow melts and these big winter events, is that we would see water stretching from the Coast Range to the foothills of the Sierra.
Wow.
And that millions of acres was something that obviously was very complicated for, development of the Central Valley, and it wouldn't be sustainable in our current landscape. I think that there's the stories of Leland Stanford taking a rowboat to his inauguration down Sacramento. And obviously we can't imagine Gavin Newsom being in that place now. We wouldn't be the fourth largest economy in the world if we still had that landscape. But I think what we missed for about 100 years was the importance that those habitats provided to not only the fish, but the work that Paul mentioned earlier with the birds, that these habitats were this very integral part of both the migrations of animals writ large, whether they be avian uses or whether the salmon. And it's not just the salmon. We see lots of fishes that require these habitats. And so I think it took us 100 years to get to that point, but we're seeing, that recognition now and trying to figure out ways to make it work.
Well said. Anything to add there, Paul?
Well, yeah, I just began to appreciate as I moved into this salmon arena that there's parallels, right, between our bird habitat work and the salmon work as well, in that, both of these groups of critters were reliant on the floodplain. And luckily, with rice farming and the infrastructure of rice fields and the location of certain rice fields being right in the remnant floodplain that is still here, which is what we call our bypasses, we do have the opportunity to give some of that habitat back to salmon. And so that's what we're hoping to do here.
Great point. I had some of the folks from CDFW on a couple of years ago talking about how, although we don't have a ton of those native wetlands left, being able to kind of mimic that with the rice fields in this area it's a good compromise, I think, between the ag needs and the environmental. So with that, I think we want to kind of dive into the details of the salmon project specifically. Can you both kind of give us an example or an idea of how the salmon project began? When did the idea of kind of restoring those floodplains by running salmon across, where did that come from?
Like I said earlier, is that when we first started working on the Cosumnes, it was the idea of kind of the idea of a natural floodplain. And there was that recognition. I think Jacob Katz at Caltrout gets a lot of credit for this, is that he's the one who said, Carson, we can't go back to the natural space, and that we do have these other opportunities. And rice is an important one. And I remember that when we first started this, it was 2009 or 10. And Jacob and I met with a couple groups of rice farmers, and I wouldn't be lying if a lot of them maybe laughed us out of those, and that it was one of the silliest things that they had heard. And it was really John Brennan at Nags Ranch who kind of gave us that first opportunity in 2011. And we carved out 5 acres of Nags Ranch out of a field on the low end of the bypass. And we put 10,000 juvenile salmon in collaboration with DWR and CDFW. And we did that. And I remember the day that we did that, there was Ted Summer that was there, Louise Conrad was there, and there was a couple of us from the university. And we were putting juvenile salmon into functionally a mud puddle. And I remember all of us thinking, like, this might be the end of our career. In that, like, we're about to kill 10,000 juvenile salmon. This is not a good thing. We used a lot of lobbying to get those 10,000 fish. And when we actually did it, we really didn't know what was going to happen. And after about 6 weeks, we saw some of the fastest growth rates of juvenile salmon that we had really observed anywhere in the Central Valley. And that was that first insight into that opportunity. And at that point in time, we didn't really understand both the food webs, the water chemistry, the management opportunities. It was really just that first insight that, yeah, this does function like a natural floodplain under, granted, it's a totally managed system, but there are aspects of it that are quite beneficial. And over the next, I think, 4 years after that is we started trying to experiment with what are the farm practices. So working with the farmers, like, are we just chopping and leaving stubble? Are we disking? Are we stomping it? What are we doing from the management perspective? What does it look like from a fallow field? and understanding the food webs, what are the management constraints of the farmers, and how do we move fish in and out from just like pulling boards, do you keep water flowing, all the things that rice farmers do. And we had no idea from the ecosystem side of things, like what rice farming actually entails. And we're a bunch of academics at the university who really don't know, we're fish squeezers. And driving around rice fields with rice farmers is a totally illuminating. I found that each rice farm is kind of like a snowflake in that they're each managed a little uniquely. But the farmer who's doing that, if we tell them what we need, more often than not, they're like, oh yeah, I'll do this, like, fine. And, there was kind of that mutual learning back and forth, like, okay, this is what we need from the fish perspective. This is what they need from the rice perspective. And it has kind of been this amazing evolution of relationships that have gotten us to where we are now.
I have to ask, is that the technical term, fish squeezer?
I mean, I think we call ourselves lots of things, but I think it's a pretty accurate thing. And that, we're running around chasing fish, and we measure fish and weigh fish. And I think that it's a little soft on the edges, but it's pretty much what we do. We're fish squeezers.
New title of the episode. When you started working out with that project and trying to, I guess, find that common ground between farmers, farming practices, and best practices for salmon, did you ever come into some kind of conflict where you found that there was a certain system that just would not work?
There's lots of things that don't work. And I think that you kind of go through those processes through, the idea that we're going to hit a home run every time we do these things is a little delusional. And I think that it's also the process of science. We oftentimes learn more from the things that don't work than the things that work. And, I think we realized pretty early on that, there's temporal constraints, there's physical constraints as far as temperature and dissolved oxygen. There's that kind of what I consider the circle of farming throughout the year is that, we can't impede on, the beginning of soil prep and those processes. But oftentimes, if it's able to be prepped, it's too warm and dry for salmon. If it's too wet to be prepped, it's probably good for salmon. And so oftentimes regulatory agencies have dates and times and permitting. And the reality is it's dictated by environmental conditions. And so we move that back and forth. And I think that we've tried to, push the square peg through the round hole a couple times with both temperature, like, oh, we can push this to mid-March because that's when we have our dates. But the reality is even in a year like what we're experiencing right now, when it's so warm, is, the end of March is not even come close to doable. It's way too warm. And there's some years like 2017 or 19 where it's still flooding in June. And so the reality is that sometimes is that, the environment doesn't go by dates on the calendar and the ecosystem doesn't either. And so we found that, you have to be flexible, which is one of the really challenging things. I think it's one of the things that when we started working this with Paul and the Rice Commission and the development of the rice practice standards, I think it's something that Paul has been integral into trying to take what we've been doing from the ecosystem side and realizing you can't push the square peg through the round hole. Like, you have to be flexible on both sides, both from the ecosystem perspective and from the farmer perspective. And I think that that's what Paul has been really helpful for us, is that, reaching out to the farmers and kind of being that liaison, like, from the Rice Commission perspective, these are the important things, and from the ecosystem and back and forth.
And Paul, your background working with the conservation groups on the bird programs must have been invaluable shifting towards this fish-oriented project. How would you say having that past experience has helped shape your leadership in this role at the CRC?
Well, it was definitely a benefit because all those years that I worked with those partners to develop the bird conservation programs, I would just say a skill of taking sort of new concepts and molding them into functional conservation programs. And certainly all that work that had been done successfully with the Natural Resources Conservation Service, they were very excited to join in this new sort of frontier of salmon projects. Luckily, I was able to springboard off of all the great work that Carson just referenced, because, right, we came into this knowing that the salmon grow very fast in the rice fields. So the next step was, how do we manage the plumbing, the seasonal sort of plumbing in respect to the rice growing season? How do we get the fish on and off these fields? How do we host them safely, given that we have two runs that are endangered? Well, one's threatened, that's the spring run, and the winter run are endangered. How do we maintain a habitat that is safe for them and all the other fish that'll be in these fields when the practice is being implemented? And so that's what we've been testing for the past 6 years or so. And it's been a very exciting ride. About half of those years were in drought, so we had some frustrations as well. But yeah, it's been quite a ride, and we're on our second round of a grant with NRCS to do this work, and we're actually going to wind down that second grant this year with the success of this last field season we did.
Excellent. Glad to hear that. So with that, what do the trials in these rice fields look like? Can you guys walk me through what it looks like from preparing the field for integration of the salmon towards, I'm assuming, taking the salmon off the field?
Yeah. So what we do is we're working with rice growers that are just in our bypass areas. It's a limited amount of acres, right? Probably about 5% of the 500,000 acres of rice are ideal for this concept. And the idea is we meet with interested growers. We go out and we visit their fields, make sure the field looks suitable for the project. There's certain evaluations we do to make sure that the field will serve sufficiently for the practice after a major flood event. And then we're just essentially waiting for the bypasses to run, bring that food-rich water in along with the fish themselves. And these rice fields then are right under several feet of water. And then when the weirs stop running and most of that water moves through the bypass, now you've got the bypass water and the fish within the four corners of a rice field. And that's really when this practice takes place. It's based on, first of all, making the water deeper. Traditionally managed rice field out in the bypass is duck water. It's 5-6 inches of depth normally. And we're going to essentially double that. Rice growers manage depth in their field with what we call boards. They're stacks of boards in rice boxes. It's more easy to see it than to hear it.
Yeah.
But that's the way that rice growers dictate the depth of their fields, both in the growing season and during winter flooding, right? But in this case, we're going to have a 12-inch stack of boards. We're going to have a 2-inch hole that is about 2/3 up from the bottom. So it's always within the water column. And we're going to have a 2-inch notch at the top of that board. These features allow for what's called volitional passage, which is very important, especially when you have ESA listed species in your habitat. They need to move when and where they want to move without any impedance, right? And so this set of boards, these modified boards, as we call them, sometimes we call them holy boards, they are in every rice box in the whole field, including the terminal drain where the water exits the field entirely. So these fish are free to move throughout the field or out the field whenever they want to. As Carson would tell you, when we put hatchery fish into rice fields, we see that 10% or so leave right away. They're sort of early exiters, but the rest of them largely remain in the field. And why not, right? They're swimming through their food. So their needs are met, right, in that system. And so we maintain this configuration until either there's another flood that comes through, or by March 1, we would then pull boards and let all the fish leave the field. we may make that decision earlier than March 1, like we did this year, based on consult with Carson about how the weather looks and all that. And again, for the safety of the fish, and what are the broader bypass conditions as well? Because there may be some more ideal times to let these fish go, depending on what's happening in the bypass that they're going to see, those conditions that they're going to see right after they leave the rice fields on the way to the ocean. So that's essentially the way the practice has been developed, is being tested. It's not yet officially being implemented as a practice standard at Natural Resources Conservation Service, but that is our end game in the next round of granting opportunities we might see from NRCS moving forward.
Great, Paul. Thank you for that rundown. I feel like that really offers a great illustrative description of what's going on during the winter flooded season.
No, I think one thing that is really important also is that, the idea that we're slowing these draining after irregular events is that historically water sat on the landscape for months. And really with the development of agriculture and urbanization is everything is graded to drain. And so the amount of time that water sits on the floodplain, even the bypasses, is relatively small because in absence of boards in place, as soon as the flooding is done, the water drains right off. And really what makes floodplains beneficial is that there's a lot of water-land interaction. And when that happens, we see lots of invertebrates. And when that happens, that's fish food, and that's when the fish are growing. And so it's that idea of slowing that draining that Paul described. When the boards are kept in with holes in them, it slows the draining. And then when we keep water flowing into them, as it prolongs it for, weeks or months, not months, but weeks, multiple weeks, sometimes months, I guess. And those are the conditions that provide the food web for the fish and allowing them to get off. And as Paul mentioned before, is that, one of the salmon strategies and why they've been successful, really throughout the North Pacific for the last, for millions of years, is that they diversify risk across the landscape. Is that when they're allowed to leave, some of them are successful. Some of them might hit the gold mine when they leave early. Some of them might be more successful when they're late. And being able to provide the opportunities across that space is what ultimately makes salmon successful. It's also what really makes them resilient. And one of the things I think that we've been missing in kind of our California salmon management is that diversification of life history strategies. And so as we provide those opportunities, we have to make sure that we're not just saying, hey, everything has to fit within this one box that is the box that we think it should be, without understanding that, there might be benefits from leaving early, there might be benefits from staying late. And salmon kind of naturally do that just through their own behaviors, and making sure we really let salmon be salmon, even on the modified landscape that we have. And so I think that that's the work that Paul is really doing and working with the farmers, is that, hey, we're making sure that they can move around, they can do all these things, and we'll just let them be salmon. I think more often than not, that when we do that, it's a better space for them and oftentimes for us as well.
For the non-fish scientist in the room here, it sounds like you're increasing the chances of survival by trying to not interfere with the intended life events in the salmon. Yeah,
exactly. What I think about it is, I think what we were talking about earlier is that, we're not going back to what it was historically. I think there's this idea in ecology called reconciliation ecology, in that, we're not restoring the system, but we're restoring some of the process, and we're reconciling that, there's really a human impact on the landscape that is so overwhelming at this point that we're reconciling that we are part of the ecosystem, and can we have some of these functions that were here historically. And I think, the Waterbird program is a great example of that, and kind of following that, we're mimicking those processes and reconciling our space on the landscape, but also the importance of the ecosystem function for birds and for fish and for all the bats, all of the things that come along when we actually mimic some of these processes on our very human dominated landscape.
I like that. And it also, I assume, makes a more resilient system as a whole anyway.
I really do think so. In that when we try to keep things in just one lane, I think that we have a great history over the last 100 years of trying to simplify the system and realizing that resiliency is not, simplification, but just like a retirement portfolio, is if you have everything in one lane, you might not be sitting pretty at the end. And it's really that idea of diversification, and it's what's made ecosystems function for millennia. So I think it's important.
We've been describing what I call the volitional passage on part of this project, which is really, really what our focus has been for the past 6-7 years or so. However, this last season saw the emergence of a pretty spectacular opportunity to do this practice for large numbers of hatchery fish. And so I thought I would sort of explain the difference, since we were just talking about this practice being used for the natural origin fish when they come naturally onto the fields. But especially the commercial fishermen groups have been observing the work that we've been doing for the last 6 or 8 years or so, or more. They became very interested in working with Fish and Wildlife Service and others to start putting hatchery fish onto winter flooded rice fields using this practice. And so in that case, the fish arrive by truck, right? And for the first time this last season, we did deploy about 2 million hatchery salmon from the Coleman National Fish Hatchery. They were put into 2 fields, 1 million fish each. One of them was at Nags Ranch, where Carson and others did their early work that he was describing earlier. And the other was at Conaway Ranch. And happy to say it was a huge success. We obviously had a bit of anxiety about, for the first time, bringing 60,000-pound fish trucks out to potentially muddy rice field environments, and if we would be able to get them in the field safely, and it all went quite well. So, and this is a part now of a 10-year Fish and Wildlife Service plan. So assuming we have enough egg take and everything is aligning, we should be doing this every year for the next 10 years, hopefully even increased numbers of fish in the future. So it's very exciting, but sometimes it's a little difficult to talk about now that we have 2 different types of this salmon management practice occurring now and will for the next 10 years.
And can I add something? I think that, Paul says is really important as well, is that one of the things that we've really been lacking that's really hard is that the ability to quantify these habitats to adulthood. Is that we know there's a lot of food. We know the juveniles grow very quickly, and that this opportunity to put 2 million fish in, that these fish are parentally based tags. So it's basically 23andMe genetics, is that we can actually take a sample off of them as adults and identify them as to these research groups that we're doing. And this is one of the first opportunities we've had to actually start looking at the benefits of these habitats, not just for that few weeks that they're out here, but the recruitment to adulthood, and does it have a positive effect? And so, really I think that it was a huge success that we were able to do it this year, but really the real information is going to come in the next 2 to 3 years as these fish come back from the ocean, because those are the fish that we count. Those are the fish that we eat and that we catch in the ocean. And so for us, from the scientific community, is that this is a great research program. I think it is really important from a management perspective, and that these hatchery fish provide us an opportunity to estimate the natural opportunities for fish that are naturally recruiting into these environments. And my personal goal is that we're not reliant on the hatchery fish in the future, but they are good. We're able to use them as a research tool to help manage our wild fish stocks better to get to that space. And I think that it provides such a great research opportunity to ultimately provide management perspectives to that space. And it's something that we have not been able to do at this point. It's, this has been we're building this house of science and management together. And there's a lot of bricks in that house. And I think that this is a really important brick, realizing that, we're on the 50-year plan at this point. And Paul talked about the next 10 years for this program, but it's really that this is building the foundation to our future management. And I think keeping that in mind as we go through this is that, we're playing the long game at this point, is that we're not going to solve this problem in a year. Is that, it's taken us 150 years of reducing the habitat. Like, we shouldn't expect that it's going to happen in even a decade. that we see really sustainable. We're seeing climate change underneath this, all of these things that are happening at once, and that, we are ultimately doing this process and building our knowledge and our management actions with all the pieces that we have on the table, and realizing that that's where our long game is ending, is that it's not even the 10 years that Paul talked about. I mean, we're really at the long game at this point if we really want to be successfully and resilient.
I'm really glad that you brought up the genealogical tags, because that kind of segues nicely into the next section that I want to ask you both about. In extension, we like to say that we're beholden to evaluations. And so what I'm really curious about is how you are tracking and monitoring and evaluating the success of this program. Can you expand on what some of those metrics might be?
So there's two things. I just mentioned the parental-based tagging, which is really, the 23andMe, that we're able to take a fin clip off of an adult that comes back and we can assign it to one of our release groups or to a wild fish that is not part of our release groups. In that, so it really is looking at the hatchery side of things, and that we can see, okay, we released this many fish, we got this many fish back, there's this much benefit. And I think that that's a very direct way for some of these hatchery populations and experiments that we're doing. The other thing that we do in my lab is that we actually look at different, what we call archival tissues of the fish. So there's two that we use in particular. One is called an otolith, which is the ear bone of a fish, and it puts on a new layer every day and throughout its life. And we can look at those ear bones, and we can look at the chemistry, particularly the isotopic ratios of strontium, and we can see which river it's from and how long it's spent in each of those rivers. And also the widths of those rings, we can estimate their growth rates. Kind of like a tree ring. So when
it
you
sounds
look
like dendrology. Yeah.
It is exactly the same thing. And so we can see where fish come from originally, both as juveniles as they leave the freshwater environment, and then as well as on the spawning grounds after they spawn and die. So we can see which rivers they're from and kind of their migration pathways. The other thing that we look at is the lens of the eye of the fish. So the lens of the eye of the fish, where the otolith is, I would consider kind of their travel journal, is how they move through the system. And the eye lens is really their diet journal, in that different habitats create different isotopic conditions and different food webs. And we can look at those isotopes of carbon, nitrogen, and sulfur, and they're not radioactive isotopes. They're stable, natural abundance isotopes. So there's no problems for, it's not like uranium. So just to be clear.
Let's get that very clear.
Yeah,
no
just to be very clear, so I'm not getting
elements.
mail later on. And so what that does is it's a really good indicator, particularly of floodplain versus non-floodplain, as well as we see resolution between, there's a difference between the Sutter bypass and the Yolo bypass and the American River floodplain, and that we see that there's very unique isotopic signatures that we can then recreate which food web within the rivers that they were feeding on. So if we can start to understand how different populations use these habitats under different scenarios, then we can start to quantify those benefits for the natural origin fish as well that are coming back, as well as the hatchery fish, to see which habitats that they were utilizing during their time on the floodplains or in the rivers as well. So the PBT, or parental-based tagging, is basically every fish that's spawned in the hatchery, we take a fin clip of that fish as they come in, and then we keep those identities more or less as we cross the males and females. And so if we know that one female has oftentimes a handful of males they will cross, and if we know those crosses from the fin clips that we take, and then we know, as it goes down the line, is we know the mother and father of the juveniles. Mm-hmm. Is that when we then collect those data for the juveniles or the fish that we're using experimentally, and then 2 or 3 years later when they come back, we take a fin clip again, we're like, oh, this was their mom and this was their dad, then we know that those different research groups, and we keep them isolated so that we can do different actions with different groups. So some fish were released at the hatcheries as small fry. Some of them were released as smolts later in the season. Some of them were held in natal homing pens in the Sacramento River. Some of them were released on the floodplain. And so as we start to understand each of these different groups, it's numbers that are the most important thing. Because, mama salmon has 5,000 eggs. Mama salmon needs 2 of those eggs to come back for a stable population. If 3 of them come back, then the population is increasing. So when we're talking about numbers, we are expecting to see maybe 2 of those fish come back. Hopefully 3 of them come back. And so when we're releasing millions of fish, those are the types of numbers that you can imagine. The ocean's a big place. We're collecting those fish from the ocean fishery, from recreational and commercial fisheries. We're collecting those fish as they come back to the spawning grounds. After they spawn and die, we collect those samples. We're collecting them as they come back to the hatchery again. And so we see these fish distributed across the landscape, and we need to be able to have enough numbers to do that. And so when we have this opportunity, which is relatively new in fishery science, is that we can now have numbers that are high enough that we can start to ask the questions scientifically and statistically to start to understand these actions, success or not success, and help guide those next decisions that we'll make in the future.
And so now that you've got those kinds of numbers, are you able to assess the survivability and reproductive success of the salmon that are raised specifically in the rice fields and the bypasses?
That's the goal, and we'll know in 2 to 3 years. This is the first year that we've been able to do it, as that technology has become readily available and the hatcheries have implemented that at scale, is that this is the first year that juveniles were released in these types of diversity of landscape actions, I guess would be the landscape scale actions. And so we'll be waiting for 2 to 3 years, and then we have to we will hopefully be running these samples pretty quickly. And so the future is, yes, we will know whether they were good or not. And some of them probably will be, and some of them probably won't be. And we will know, kind of understanding that as it goes forward, is that which ones were and which ones weren't. Did we see increased stray from certain actions, so that they went to different rivers that we necessarily they weren't supposed to be in? Were they, did they come back to the places we expected them to come back to? Did they come back in larger numbers? Did they come back in smaller numbers? Those are the actions that we're looking to get at from this type of kind of science and management questions that we're asking.
So that sounds like really exciting stuff is on the horizon. Is that part of the grant that you were talking about earlier, Paul, with the NRCS?
Yeah, well, the grant from NRCS pays, grower, landowner costs. A lot of that science that Carson was just talking about in terms of monitoring the PBT fish when they come back, that will not be funded through an NRCS grant with CRC. Where we plan to go with our next NRCS grant is to basically roll this practice out now that we've tested it, for half a dozen years, and we understand how it can be implemented and what the costs are, et cetera. We're looking to roll it into a mature type of program, much like our bird programs are operated today, where just any eligible grower that's interested in participating can apply for the program and be evaluated and potentially selected to participate. So that's what the NRCS funding will do.
You've mentioned a lot of collaborator agencies working over the last, I think, almost 20 years of this project. I think we've mentioned CDFW, NRCS, CalTrout, CRC. Are there any others that we'd like to mention here?
In that list, of course, includes U.S. Fish and Wildlife Service, who has adopted this 10-year plan on the hatchery fish side.
I would also make sure to include DWR. They've been partners really since the beginning in this as well, and continue to fund our research for monitoring these habitats over time. I would say state water contractors, Metropolitan has helped us a lot as well. It really does. I think when it boils down to it, we are all part of this watershed, right? In that, from water users, and water users come both from municipalities and agricultural water users, as well as environmental water users. I would say River Partners has been a big, as I'm talking, I'm thinking about all the people who've been part of this, and I'm surely going to miss some, but it's been really, it does take all of us because watersheds are so integrated, and we're all part of a watershed. I think of even Southern California as part of the Sacramento River watershed, because some of their water comes from it as well. And I think that recognition has been really important for them and their water users to realize that this is part of their obligation to help support this as well. And so it has been just an amazing diversity of people, and it has been a process of building kind of that community over time. Is that, like I said at the beginning, it wasn't always It was a silly idea. And sometimes silly ideas work. Sometimes they stay silly and don't work. And as it's kind of built, it kind of has a life of its own at this point that we did. I don't think when we started this, we expected the idea of, nigiri is really what it was. The idea of salmon over rice. And when we first branded that, it was kind of joking. And I think the idea is that it has a life of its own now. And the realization that it is one of the most important things that we could put on the landscape it's the biggest opportunity that we have. Like I mentioned earlier, we're not going to go back to hundreds of thousands of acres of natural floodplain habitat because of our flood control infrastructure. Our need for growing food, all of those things have kind of limited what we can do there. And so the idea is that, I think sometimes people need to hear a good story with a good, kind of theme that weaves it together and have it be meaningful. And I think that that's something that has been different than lots of the other just sciencey work that I've done in my career, is that it's a story where people can actually see themselves in it. And I think that that's important.
I would also, of course, mention National Marine Fisheries Service.
Yes.
They're responsible for approving the BIOP at which we operate under for the natural origin fish to be managed in this way. So very important permitting role. We did mention CDFW. They also have an analogous permit on the state side because those two runs are both state and federal listed. Also, I would mention an organization called the Bridge Group, which is the fishermen groups, the water districts, and farmers working together and with all of those agencies. So the fishermen groups really have been instrumental in helping us move on this hatchery fish program that I referenced earlier.
And I also probably the growers who have been letting all of this happen on their rice grounds as well. And I'm sure there's too many of them to name, but
well, at this point, it's somewhat of a limited number, and one of the reasons is because I mentioned that for this natural origin fish practice, it can only be done on about 5% of rice acres. So those lands are controlled by a limited number of growers. But certainly guys like Steve Nieder and Mike DeWitt, John Brennan, Conaway Ranch, folks over there, that they've all been very instrumental in helping us move these projects forward.
And I would add even more, Paul, is that I think, that we think of this from the fish perspective, is that there's two things. Is unlike birds, fish can't get over levees. And so we think of this as there's the wet side of the levee, which are the bypasses, but then there's also the dry side of the levees that are oftentimes beset. And we've realized that we can flood rice fields as part of the regular practices that the water birds are happening, but then we can drain that food-rich water back into the river and subsidize river habitats as well. And there's been numerous farmers that have been part of that process as well, where we try and bring the food to the fish when we can't bring the fish to the food. And so there's been tens of thousands of acres that have been part of that program over the last few years. And there's too many names to mention there. But again, our dry side farmers are also really important in this process because we can't just do it with, Paul said it's limited number of acres that we have within the flood bypass system, but there's also a lot of opportunities outside of the flood bypass system where we can also have benefit with, relatively little cost.
Yes. And in this next version of our NRCS project that we envision, as soon as NRCS announces that the program is open, we plan to apply. We're already working with CalTrout on having some of those resources go to the fish food program, as well as our bypass practice, both supporting the natural origin version of that, as well as landowner costs for the hatchery fish work that will happen over the next 10 years as well. So this next version of our program should be inclusive of all of those things.
That's very exciting news on the horizon. And I know we've said, yes, this is a long scale plan. This is a 50-year plan. But there seems to have already been so much discovery and so much work conducted in the last 10, 15 years. It really makes you optimistic to see what the future holds, at least from this perspective.
Yeah, realize you have to be optimistic anymore if we're going to keep going forward. And so, but like I said earlier, is that, we've also failed spectacularly on some of these. But it's really important, that process of learning is to be optimistic is you have to put yourself out there and realizing that not everything is going to be perfect. And, ecosystems and management are not perfect, and it's not always what you think it's going to be. And learning is the thing that has changed us and how we move forward. And I think that's the thing that gives me optimism, is that we can continue to learn and evolve, realizing that lots of the things are changing beneath us. And it's not a static system. It's not a static climate. It's not a static political space and management space. And that we need to continue to move forward and evolve with the changes that we see happening around us.
With that, is there anything else that either of you would like to mention before we wrap up?
Well, I would, of course, like to mention that all of this work the Rice Commission has been doing for all these years couldn't be done without substantial funding, right? To this point, we've invested about $2.5 million in getting to where we are today. About half of those funds, almost half of those funds, have come from the Natural Resources Conservation Service. So big shout out to NRCS there. But also we have a large group of private donors as well. They can all be seen at the website salmon.calrice.org, inclusive of the state water contractors, Syngenta, Grow West, a number of our rice farming groups. A whole group of folks have rallied together to provide what we call matching funds, right? All those funds that we get from NRCS need to be matched, and they have been matched by a coalition of groups that have joined the Rice Commission in this work.
Yeah, and I think in addition to just, the general funding sponsors, is that, when a bunch of ecologists reach out to a bunch of farmers to start doing things differently and thinking about it differently is the patience that both Paul and others have had with us. And I think that I'm very grateful that I can now drive around rice country and understand what's happening more so than I certainly could before, but also realizing that, we are a bigger community in that space, and that when we actually learn from each other and, realize that it's not just our one little thing, is that when I first got in this, I'm like, why can't we just make it fishy? Can we just do that? But realizing that there are boards on that space, on what we can actually think about, both figuratively and literally. And that, that learning and transfer of knowledge from the things that we do to others is really the thing that has been valuable for me, learning a lot. And I hope that some other folks have found it useful in the other direction as well. But I think if we're going to really inflict change, it has to be in that space of mutual learning and communication, because if we just sit in our own boxes, we never move it forward. And so I'm really grateful to all of our ag partners who have been in that space, and as well as just kind of everything from school kids, everything. It's amazing that we have this opportunity to have the conversation with anybody who will listen. And I think that bringing along everybody in the community, it's not just the farmers, but it is really the community of people who need to value this if we really want to move it forward, because that's how things actually change, more than just management decisions. It's really community change and community backing that makes it happen.
Finally, I want to recognize, of course, UC Davis, Carson's team, Andrew Ripple before Carson was leading the project. Now Carson's leading it. But again, on our website, a lot of videos there showing the nature of the field work that UC Davis has done all these years. It is tedious. It is every day. It is muddy. It's amazing work that they've done. And oftentimes I give all these presentations and I need to pause and I say, when I say we, I mean mostly UC Davis out there day after day collecting all of this data, and the lead scientists in the field, first Rochelle Tallman and now Alex Wampler and a whole team of students that come out and do this work again during the field season, 7 days a week. And it is very, very tedious work. So I'm very appreciative of the partnership with UC Davis here on all this science.
And we love you too, Paul.
I'm just hearing a lot of collaboration and cooperation here, and that's just what it takes. And it's amazing to see it in action on a project like this. With that, I think we're going to wrap up. Paul, Carson, is there a way that people can reach out to you if they have any more questions or want to get in contact about this program?
Well, I'm at pbuttner@calrice.org.
And you can reach me in my email at cajeffres@ucdavis.edu.
Perfect. Well, thank you, Paul. Thank you, Carson, so much. Really appreciate your time. We're definitely going to have you back on if you're willing, but you've given us a lot to talk about here today and a lot to think about. So again, thank you so much.
Thanks for having us.
Thank you, sir.
We have a couple of upcoming events we'd like to share with you. On July 30th, UCCE will be partnering with the California Rice Commission to hold the Rice Quality Workshop. That will take place at Hillcrest Catering in Yuba City and will go from 9 till noon. This meeting will also have registration required, and although that link is not available yet, as soon as it is available, we will have it up on our websites. For more information about these and other upcoming events, feel free to check out our resources, which include the UC Rice blog and the UC Agronomy Rice website. In terms of other resources you might want to take advantage of, you can also look at our newsletters, which include Rice Briefs, which covers Collusiolo, Rice Notes, which covers Yuba Sutter, Rice Leaf, which covers Butte and Glen, and Field Notes, which covers rice in the Delta region of California. Thanks for listening to Thoughts on Rice, a University of California Cooperative Extension podcast from the University of California Agricultural Natural Resources. You can find out more about this podcast on our website, thoughtsonrice.buzzsprout.com. We'd love to hear from you, whether it's from using our text link in the show notes, a survey submission in our feedback form, also in the show notes, or in a comment or rating on your podcast streaming service of choice. You can email me with any comments, questions, or concerns at smarsh@ucanr.edu. Another year has begun, and it feels like planting is right around the corner. And remember, like the growers like to say, have a rice life. Mention of an agrochemical does not constitute a recommendation, merely the sharing of research findings. Always follow the label is the law. Find out more at ipm.ucanr.edu. The views, thoughts, and opinions expressed are the speaker's own and do not represent the views, thoughts, and opinions of the University of California. The material and information presented here is for general purposes only. The University of California name and all forms and abbreviations are the property of its owner, and its use does not imply endorsement of or opposition to any specific organization, product, or service.